Okay, let's take a look. Okay, so we've taken this big triangle and we've made this clever division right here. First thing we notice, if this is a right angle, then this over here would be a right angle. So I've taken this one right here, this bigger of the two, this bottom slice here, and I've kind of rotated it and flipped it. So D is down here. That's got a right angle in it. Okay, B is over here, and then C flipped up there. So let's take a look at this. If I put one arc in that, I can put one arc right there. Let's do the same thing on this one. So A comes over here, C flips over there, and D is right there. Again, D has a right angle on it. So if I put two arcs on this one, I can put two arcs on that one right there. Don't need anything else to show that those two are similar. That the big triangle is congruent to this one right here, and that the big triangle is congruent to the one on the end. What's the similarity theorem that allows us to do that? Luke? Angle similarity. So would you write angle similarity right there? The other thing that we want to notice is everything marked the right way? We've got this big side C here that's been split into a piece that's E up here and D down here. So when I flip this over, D to B, yep, that's D. And then this side over here in between C and B, that's A. And then over on this one, from A to C, yep, that's marked as B over here. And from A to D, yep, that's marked as E. So is everything accurate on here, labeled correctly, and are these all similar? Perfect. Can somebody tell us what that factors to? The one on the top. A squared plus 2AB plus B squared. This was one of the last ones that we learned. It comes in unbelievably handy. D? Okay, so A plus B in parentheses times another A plus B. So we can just write square. Okay, this is the right answer. Raise your hand if you got that. Ooh, very nice. Does anybody remember the name of a trinomial that looks like that? That. Close. Perfect square trinomial. This trinomial came from a perfect square. So the way we check this is, does it start with a perfect square? It does, of A. Does it end with a perfect square? It does, of B. If you multiply the two of those together and double it, do you get the right middle term? So multiplying them together, you get AB. And if you double it, you get 2AB. This happens to have pluses all the way through, but it's possible to have the 2AB be a minus. And then the only thing that changes is that instead of having A plus B quantity squared, it's just A minus B quantity squared. Perfect square trinomials. If you remembered that, it's been a long time since we've seen those. That's really good that you've locked that away. Any questions on the warm-up or the factor? Okay. Then I think you're going to like this. Okay, you've seen the Pythagorean theorem before. You've used it quite a bit. But in this class, we're going to extend it a little bit by actually proving that it's true. Now, proving sounds really horrible, but I think you're going to like this. Okay, so here's the idea. We want to make sure that we understand how theorems work. There's an if part and then a then part to every single theorem. So the if part we call the hypothesis. So if this, then that, and the that part, the then part, is called the conclusion. So whenever you're working with theorems, you want to make sure that you understand the hypothesis part. All of the hypothesis part has to be true. If this, you've got to make sure that all the if stuff is true, and then understand all the conclusion part. So this is the Pythagorean theorem. If a triangle is a right triangle with a hypotenuse C and legs A and B, then A squared plus B squared equals C squared. So the hypothesis part of this is what? What's the if part? Lizzie?
If we have a right triangle with a hypotenuse labeled C.
Yep. So if we have a right triangle and it's labeled accordingly, okay? So I'll write labeled A, B, C accordingly, okay? So if we do that, what's the conclusion, Wilson?
The Pythagorean theorem.
Which is?
A squared plus B squared.
A squared plus B squared equals C squared. Now, if any of you had me for when you saw the Pythagorean theorem for the first time or got it used again, I normally don't teach it as A squared plus B squared equals C squared. because people remember the letters, but they don't remember what it means. Does anybody know how I usually teach this? Luke?
Leg squared plus leg squared equals hypotenuse
So
squared.
here's what it means, and this is why I like this better. If you remember leg squared plus leg squared equals hypotenuse squared, it reminds you that what we're doing is we're squaring the two legs, and this is not the only way to state the Pythagorean theorem. But if you just remember this phrase, it tells you a whole bunch of information just in the way we say that. Leg squared plus leg squared equals hypotenuse squared. Number one, if you've got a hypotenuse, you must have had a right triangle. The other two sides are legs. So what we're doing is we're squaring the legs, we're adding them together, and it equals the square of the hypotenuse. Okay? That's what it means. Now, if we're going to make sure that this is an accurate diagram that depicts the Pythagorean theorem, what might we want to add to this so people could tell by looking, oh, this is what we've got? Because there's a couple things missing here. There's at least one that's super important.
Right angle.
Thanks for just shouting that out for everybody. Jack?
Oops.
What is it?
Right angle.
You got to have the right angle in there. Okay. What else could we put on here that would be a visual and tell everybody, hey, this is a right triangle and here's the Pythagorean theorem? What shape are these? Squares. So I could put c squared here, b squared here, and a squared here. Okay. That would be a visual for that. Now, what we're going to do is you can find hundreds and hundreds of proofs of the Pythagorean theorem. Some are very long, some are very short. Okay. We're going to do our own in just a second, but what I want to do here is I want to show everybody a couple of these. So I'm going to come back over here, and as these are demonstrated, I want you to figure out, is this an actual proof or is this a demonstration?
Well, it says demonstration right there.
Thanks. Demo, right? Okay. Watch, they'll flip it over. So now everything's in c squared, and all of the water in c squared is going to end up in the leg squared.
It's so freaking cool.
Okay.
That's crazy.
Okay, so that's a visual demonstration, a water demonstration. Okay, and then here's this. Apparently my audio is not working. There we go. That parallelogram would have the same area of the square. This is using the principle of parallel slices, also called Cavalieri's principle, I believe. And then they're going to drop those down here.
What?
Drop them right in there.
How did that work? It says, but it didn't.
Okay, you might want to watch that again. These, you've got links for these. President Garfield actually came up with a proof of his own. This is a little bit longer, so go ahead and watch this. Very, very. Museum is what the other people call it. RHS, right inside. Something there should look kind of familiar. So QED, if I remember correctly, stands for quo erratus demonstratum or something like that. So it means thus is what Okay.
Oh, I like this. That was
See if you like what we do a little better. Let's speed this up just a little bit. Whoops.
Oh. This is.
Got a plus b quantity squared. We're going to see that somewhere. Right? These are the short. Okay, so here's what we're going to do. We're going to do this our own way.
hooray.
Okay, now, if you want to finish watching that, you're welcome to. If you want to Google or go to YouTube and do proof of Pythagorean theorem, you'll find hundreds and hundreds of videos. Some are very good, some are kind of awful. So if you want to take a look at this, here's what we're going to do. Okay, we already figured out that those are similar by angle-angle similarity, correct?
Yeah.
Okay. You ready? Because this is going to go quick. So here's what we're going to do. We've taken this triangle and we did a clever division like we showed up above. Now we're going to set up some clever proportions. So here's the first thing that I want you to notice. The only thing that we really know about the sides of this triangle right here are just A and D. So I'm going to put A over D right here. Thanks. Struggled with letters. Okay, what does that match up to over here? It matches up to this long side right here, which I'm going to write as D plus E, put it in alphabetical order, over A. Then I'm going to do the same thing, but in a different color for this one. The only thing I know about this one right here is I've got B over E, and what would that correspond to over on this one? Well, that would be the hypotenuse. So this is going to be D plus E over B. You're right about that. We're good? Don't worry. Don't worry. Is this right?
I think so.
Okay, watch. If I do cross multiplying here, I get A squared equals D times D plus E. And on the other one, if I do the same thing, I'm going to get B squared equals DE plus E squared. Am I right about that?
Yeah.
Okay. I skipped a step on that one. Let me just catch up here. This is D squared plus DE. Am I right about that? Okay. If this is a true equation and that's a true equation, can't we add true equations together? Okay. So add them together and here's what we get. We get A squared plus B squared on this side. And then on the other side, we get D squared plus DE plus DE plus E squared.
Ooh, and it's the one thingy that equals C.
Those two guys together, so we've got A squared plus B squared equals, this would be D squared plus 2DE plus E squared. Now, haven't you seen something that's kind of like this right here?
The one up above.
The one up above. So that would be D plus E quantity squared. So A squared plus B squared would be equal to D plus E quantity squared. And Wilson, what's D plus E?
C.
We just look over at the diagram. D plus E is that long side C, so that means that A squared plus B squared equals C squared. So we started off with a right triangle, did a clever division, broke it into two similar right triangles,
Let's be on the
and then just used proportionality to figure out that A squared plus B squared equals C squared.
Did
Wilson?
you figure out that yourself?
No.
Will this be on the test?
It'll be on the assignment for sure. Okay, so you want to know that. We'll see. Flip it over.
We have this on.
Maybe. Yeah.
I was just confused on like what letters you're talking about. Like uppercase A's and B's or whatever.
These are all lowercase. These are side lengths. So by convention, listen up,
So why do we find angles?
I don't know.
Wilson. By convention, we use capital letters for points and we use lowercase letters for lengths of sides. Okay. All right, so flip over on this side right here. It says solve for x. Nothing complicated here. I would prefer that you not think A squared plus B squared equals C squared. I would prefer you think leg squared plus leg squared equals hypotenuse squared. So 3 squared plus 3 squared equals hypotenuse squared. 9 plus 9 equals x squared. 18 equals x squared. We can solve this quadratic because that's what it is by taking the square root of both sides. So we get x equals, and then I probably ought to simplify this a little bit. 18 is 3 times 3 times 2. So 3 radical 2. Put a box around that and you're done.
Hooray.
Next one. Leg squared plus leg squared equals hypotenuse squared. So I'm going to do x squared plus leg squared equals hypotenuse squared. Probably ought to put parentheses around those just to kind of be on the safe side. This is going to be x squared plus, I'm hoping somebody knows 25 squared.
625.
It is 625.
Mm-hmm.
And you've all got 65 squared memorized, right?
4,220.
Yeah.
Okay.
That is locked away.
Which is pretty convenient because when we move the 625 to the other side, we get x squared equals 3,600. Do not say anything out loud. Sure, that's a big number, but Sai?
I'm confused.
About
I don't know.
This is cool. Wait.
square root of 3,600.
60.
60. So this side right here would be 60. Okay? All right. Last little bit. This looks horrible. Both of these look pretty awful. Let's take a look at this one. I know you don't have D. Okay? I want you to write D on there. Okay? So C looks like this, and we've got to find the diagonal of this rectangle. Leg squared.
That's easy.
Mm-hmm.
Oh.
plus legs squared, whoops, equals hypotenuse squared. Don't say anything out loud. I need somebody to raise their hand. What happens here?
Oh my goodness.
Hold on. Keely, what happens? The squares cancel the square roots. They're inverses. So this is a 23. This is a 26. So this is a 49 equals x squared. So we get x equals 7. Okay.
That is literally
Okay. Set up the next one. Okay. Next one is D. I know it's not on yours. Would you go ahead and write that one? Set up D. And do legs squared plus legs squared equals hypotenuse squared.
I guess. I hope that's right.
Who's got it? Hang on a second. I need the correct answer, not in decimal form. I need radical form.
I got it.
Crew, you think you got it?
Yes.
What do you think it is?
4 square root of 5.
Luke, what do you think it is?
4 after 5.
4 radical 5. Take a look.
Yes,
Yeah,
that's what I
radical.
Okay. Here's why this is on here, just to double check and make sure. When you square this, we square the 2, that gives us a 4. When you square the square root of 5, they cancel each other out. They're inverses, so we get a 5. That's a 20. Move it to the other side. We end up with the square root of 80. Any questions?
Jack, what did you do wrong?
I didn't square the 2.